So, good morning. I'm very pleased to be the opening act here. I am also very pleased to welcome you to Colorado. The title of my talk is Moab Workload Manager in the SMB Small and Medium Business HPC Environment. So, I work for Techx Corporation. We're from Boulder, Colorado. It's about 40 minutes northwest of Denver. And we enjoy proximity to the University of Colorado, Ceres, NIST, the National Institute of Standards, many other scientific companies and venture capital firms. Our business consists primarily of software, scientific software products, consulting services, and federally funded projects. This is a picture of Boulder. If you have a chance to come up, we welcome you for a visit at our facility. I wanted to take just a few minutes to tell you about our environment that we use Moab in, because we don't have this. But yet I find that Moab is really, really useful in our environment. And so I wanted to tell you just a little bit about our company, first of all, what we do. And then I'll talk about how we use Moab and what we found to be valuable for us. So our primary product is a particle in cell or PIC simulation called vSim. And it runs on the Vorpal engine. Shown over at the right-hand side is a laser Wakefield image simulation of a radio frequency gun and a particle accelerator. There's on the bottom is a plasma simulation done by vSim. So the Composer Toolkit is integrated across all of our scientific software products. And shown here is the vSim Composer. So it's the front end to your run setup, the run management, whether it's either on a local computer or it's on a local a cluster that might be in your environment, or it might go to an LCF, leadership computing facility or a supercomputing site. So our software runs on laptops up to tens of thousands of processors at leadership computing facilities. The software visualization is all done using Visit, which is, they have a booth here, and you'll find that at many of the leadership computing facilities. vSim is a fluid plasma modeling framework that simulates the dynamics of charged fluids or neutrals. So we modularize our products, and shown on the right-hand side is vSim for hypersonics. So that's used for simulation of charged plasmas in hypersonic flight, scramjet detection, or reentry vehicles. GPU-lib is a product that allows people to access high-performance computing with minimal modifications to their existing code. So it requires no knowledge of GPU programming or of memory management. So our company both sells this as a product, and we port to GPU hardware. And right here at the bottom left-hand side is shown one of the NASA Hubble Space Telescope images, a deconvolution using FFTs under GPU Live. So Orbiter is another product that is produced by our systems integration group out of Buffalo, New York. And Orbiter is a secure and fast framework for access using either a thin web-based client or else a thick desktop application. So Orbiter, shown here, is the spallation neutron source at Oak Ridge National Laboratory, and Orbiter facilitates the communication and collaboration with the neutron science community by providing access to the experimental dashboards and also to experimental data through a virtual file system. So shown at the right is the integration with Oak Ridge's authentication and validation system. I think I just have one more slide about what we do. We have collaborations with NASA. So the Ceres project generates cloud products. We do the scientific analysis to generate those products for the imagery that comes from the Terra and the Aqua satellites. So what I wanted to just start out with these slides is because just to show you that Techx is a very rich and varied scientific environment. We have multiple and diverse projects, multiple deadlines. We have daily builds by our QAR division. We have scheduled regression testing that happens. We have very competing priorities, and with all organizations, we have a very limited IT staff. And I think that is the main key. So where Techx uses Moab, we have a 32-node in-house cluster. We do not use Moab for several smaller clusters that we maintain, either for collaborators or for dedicated projects. And so my experience with Moab, or let's see, basically with PBS and Torque, is approximately 8 years of cluster management. And then with Moab, we've used Moab for about 3.5 years. Let's see, we use our 32-node cluster for testing, development, and prototyping. So we also use it for commercial contracting projects that will fit into about a 64 core simulation. Sometimes we'll use it for a proof of concept for a sale of our product. So larger jobs are all generally transferred to one of the bigger computers, which we might have access to. Either it might be a nurse computer, or it might be a NASA computer, or another agency computer. So what Moab provides for Techx, and I think these were just words that I came up with from our experience. Fairness, predictability, transparency, reliability, epilogue scripts, interactive queues, and technical support. So our Key Organization, because we have a small organization, we're not like a nurse, although nurse does always have a nurse user group. We have a computer meeting at least once a year to talk about how the Key Organization is working out. So I think that's one of the very important things for us, is that we have a lot of user input depending on the projects that are going on at the time. It's always documented on our wiki, and that's not to say that we might not have unusual requirements, which we try to accommodate. We may have a sale which requires a proof of concept, or we may have, let's just say, an invited scientific paper that requires some unusual calculations. So, but I think that one of the main key is that we have user input depending on what's going on in our community, and then we also have key priorities that are set by our user communities. So these are our queues. It's not we don't have a big environment. The medium queue is probably the most used for simulations. The small queue we prioritize for small jobs. The serial you can use up to 8, put up to 8 jobs on one node, or one if it's a large memory requirement. The debug queue, you can use that for testing your input parameters, but you only get 20 minutes. The low queue is for large jobs, which you can run 96 hours. And the interactive queue. So the interactive queue is a time limit of 4 hours. So the biggest productivity boost that we have gotten with Moab is the implementation of the interactive queues. It eliminates complaints about people compiling on the head node or doing a very large visualization job on the head node. We have 2 head or master nodes on our cluster that do round-robin routing for login. Two nodes are dedicated 24/7 because we have people that work during the weekends for the interactive queues. And then during the weekday, we have an additional 2 nodes that are dedicated to the interactive queue just during the work hours. And any other node that is not reserved can be used for the interactive queue. It's always prioritized, so you see that the priority for the interactive queue is 100, so your interactive job will always take priority over other jobs. So this means that people's work time is the most valuable, and they can get those resources during the workday when they need them. Any bash variables, if you're not using that node, you're kicked off. So users are suggested by, you see that our maximum time for most of the queues are 24 hours, so everybody gets their time slice. Users are suggested, if they know their job is going to complete in 6 hours, to request 6 hours. But in reality, most people will request the maximum time. So that's one thing that it's a courtesy to other people, but so that other people know when their jobs will start. But in reality, they generally just use the maximum time. By default, we give them 30 seconds. So if you don't request a wall time, then you will get kicked out after 30 seconds. Okay, I think we try to empower users, and I realize that some of this is done transparently, probably through Moab, but our users look at when they can get their job output, when their job will start. QStat -A is from the torque commands. It runs across all of our clusters, but the following commands are from Moab, and I think that these are really important for any queue user to understand. Show queue, show start, show reservation, show backfill. So show backfill has been very useful in being able to see how many nodes are available and for what period of time. And so maybe you can just squeeze a job in with the available resources that are free at that time. mdiag -n shows the health of your entire, of the nodes. So the resources that we have found, or that I thought were very, very, very useful, were Moab Key. And it's an opportunity not only to interact with other people that are doing the same thing that I'm doing, such as managing a clustered environment, but also to interact with the staff at Adaptive Computing. I don't know, it may have gotten a lot bigger since I've been there, but I just found that it's really useful to be able to have that interaction at Moab Key. Adaptive Help, their help desk and their ticketing system have been really great because I do not have staff to become workload managers. Workload management specialists. We are not Moab specialists. So we use the ticketing system as a consulting service for, this is what our users want to do. How can we do this? So I think it speaks to just the limitation of staff probably in all IT environments where you're covering a lot of different areas. The BOFs are really, I think, useful times to listen to the user community. There is an adaptive BOF called Torque. Where are we now and where are we going? That is today. And then there's one tomorrow for the PBS community, and I would go to both of them. I think that the BOFs are really great exchanges of information. We use OpenMPI, and the mailman list is like instant gratification. It's a great mailman list if you have questions. And then there's also MPitch. We're currently not using MPitch, but the mailman lists are really useful. So this is just a summary of our experience with Moab over the last 3.5 years. Because we have a user-defined input, that it has eliminated many of the complaints and many of the questions to our system administration staff. Moab has brought to Techx many of the benefits that running in a large facility such as NERSC or some of the other LCFs. It's allowed our users to have those benefits. So I think fairness, just repeating here, predictability, transparency, reliability, epilogue scripts, and especially the interactive queues have been a great positive for us in our development environment. So, our URL is at the bottom of the sheet, and my email if anybody has any questions. And that is